Hello, Algebra 2. Thank you for watching. Thanks for tuning in. How's your day going? Leave a comment on the video if you're watching on YouTube. Smash the like button. All right, I'm done. ACT prep, once again. ACT prep. Let's jump right into it. Let's try to knock out as many problems as we can here. 41. For 20 quiz scores in a typing class, the table gives the frequency of the scores in each score interval. Which interval contains the median of the scores? A median is the middle number. The median is the middle number. So how many numbers are there? 3 plus 1 is 4, plus 3 is 7. Okay, so that's 7, plus 4 is 11, plus 9 is 20. So the middle number, 20, that's 10 and 11. 10 and 11. So where are the 10th and 11th number is what we're asking, right? Because to find the median, you'd average those two together, right? There's 10 numbers over here, 10 numbers over here. So the 10th and 11th number. So 3, 4, 7, and then right here, right? 8, 9, 10, and 11. So the 81 through 85, option D. All right. I don't care what the median is. I don't know what the median is. I just wonder where it's at. Complex numbers. We've seen I on occasion in our class. I squared is equal to -1. So let's solve this. Well, this is a lot like what we were doing with our rational expressions. And if you have the same thing on top and bottom, you can cancel it out. If you have the same thing on top and bottom, you can kind of cancel it out. So let's just kind of see what happens. This is the same thing as multiplying by 1, right? So this times 1. Well, that answer, this on its own, isn't showing up. So there's some sort of trickery that's happening. So let's go ahead and multiply it together. I mean, I gave it a shot, but it didn't work. So if I multiply it together, I'm going to have 1 times this. Well, that's just 1 minus I. And then 1 plus I times 1 minus I on bottom. Can we multiply this together? Yes, we can. We can use our box method. So we have 1 plus I and 1 minus I. 1 times 1 is 1. 1 times -1 is -I. 1 times I is 1I. And -I times I. Well, I squared is -1. But if you have a negative, that's a -1. So +1. So the two ones combine to be 2. And I minus I actually cancels out. So we're just left with 2. 1 minus I over 2. Option J. So we gotta remember how to use our box method. And the way those cancels out is real pretty. Okay? Temperatures measured in degrees Fahrenheit are related to temperatures measured in degrees Celsius by the formula blah, where there is one value for x, which x degrees Fahrenheit equals x degrees Celsius. What is that value? So we want to know, when are F and C the same? Well, that means that we could replace F with F, right? Or we can replace C with F. These are actually the same thing. We don't have to use two unique variables, right? F and C are equal. Let's just call it X, right? They're the same. They are the same value, right? When it's 38 degrees Fahrenheit, it's 38 degrees Celsius. Or when it's -40 degrees Fahrenheit, so we just want to know, when is this equation true for when they're equivalent, when they're the same thing. So let's go ahead and solve. We need to get our x's together. So we need to subtract 9/5 x, which I know might be sort of stressful for you with fractions. So let's get rid of these arrows. That's kind of confusing. Minus 9/5. So off to the side here, 1x minus 9/5 x. Well, that's the same thing as 5/5 x minus 9/5 x. So 5 minus 9 is -4/5 x equals 32. And now how do we get rid of the 4/5 to solve for x? Well, you multiply by the opposite reciprocal to cancel that out. Whoops, I wrote a 2 when I meant 4. So x equals whatever that is plugged into a calculator. 32 times negative 5 is negative 160 divided by 4 is negative 140. Negative 140. Now, this is a situation where, it's funny that I circled negative 140 as the theoretical answer. I truly didn't know the answer. This is a situation where you could just simply plug it in and see if it works out. And by that I mean, if you plug in 72 times 9 divided by 5 plus 32, the answer is not 72. I got 161.6. But if you plug in negative 40 times 9 divided by 5 plus 32, oh, I got the same answer, right? So I knew how to solve it right away, and I just dove right into it. But if you're like, plugging it in might be the quicker option for you if you are second-guessing yourself. The table below gives experimental data values for the variables x and y. Theory predicts that y varies directly with x. Based on the experimental data, which of the following values is closest to the constant of variation? Note, the variable y varies directly with blah, blah, blah. So they're saying that there is some value that we can multiply x by to get y consistently over and over. There is some value. So with that being said, let's just plug it in. If y equals 0.140 and x equals 2.75, simply solve for k, right? That's how I'm interpreting that, right? If this is the equation, k times x, we'll plug in x, plug in y, see what happens, right? This is 0.140, don't get your decimals mixed up. So 0.140 divided by 2.75 is 0.0509. It continues on forever, but the only real answer that makes sense is G. You can also tell here that the numbers are getting smaller, and sort of by, just by a logical conclusion, you can't multiply by 20 and somehow get a smaller number, right? None of these make sense. Also, none of these answers are negative, so multiplying by a negative doesn't seem to make sense either. In all honesty, that's the only answer that makes any lick of sense. During a snowstorm, the relationship between the depth of accumulated snow, y inches, and the elapsed time, x hours, was modeled by the equation blah. One of the following graphs in the standard form xy coordinate plane models the equation. So when I see this, when I see all these lines, I look at this and wish it was in slope-intercept form, because I can see the y-intercept in each of these, and I can sort of approximate the slope by counting the rise and run. But when I look at this, I don't know what I'm looking at. So I want to convert this into slope-intercept form. So 2x minus 5y equals negative 5. Let's solve for y. So subtract the 2x, negative 5y equals negative 2x minus 5, and then divide by negative 5. That cancels out, of course. That becomes positive 2/5 x, and then those two negatives become plus 1, negative 5 divided by negative 5. So which one of these has a y-intercept at 1? Well, that would be option B or A, out, out, out. So now it's a matter of which slope looks correct. Up 2 over 1, 2, 3, 4, 5, right? That's exactly what this is. This is going up 5 and over 2. Option A is your right answer. All right, beautiful. We've done 5 questions in less than 10 minutes. Let's try to knock out a few more to give us that much more time during class to talk about these. So, Diana is baking bread, and the original recipe calls for 1½ teaspoons of yeast and 2½ cups of flour. Diana will use the entire contents of a packet that contains 2¼ teaspoons of yeast and will use the same ratio of ingredients called for in the original recipe. How many cups of flour will Diana use? So she's using, let's review that. It calls for 1½ teaspoons of yeast and she's using 2¼ teaspoons of yeast. So did she double the recipe? Did she triple the recipe? Right? That's what we're essentially looking for here, right? Because if she's following the recipe, right? If it says she's using the same ratio called for in the recipe, what did she do, right? She took if the recipe calls for 1½ teaspoons, did she double it? Did she triple it? What'd she do? Well, I don't know what she did, so let's call it K, right? What did she multiply by? Times 2, times 3. Hint, the answer is not a whole number, right? The answer is not a whole number. 2¼ is 2.25. So let's solve for K here. We divide by 1½ and we get 2.25 divided by 1.5 is 1½ So she, 1½ times it, right? She used 150% of what was called for. However you want to think of it, right? She didn't quite double it. She multiplied it by 1½, right? So maybe the recipe called for, it was 4 servings, and she didn't want 8, she wanted 6. So 4 times 1½ is 6, right? You see, this is real life, right? You might not want to double your recipe and make too much, right? But you also don't only want 4 servings, right? You got to find that middle ground. So you multiply it by 1½ Well, if she multiplied the yeast by 1½ she's also going to multiply the flour, 2½ cups, by 1½ right? If you're going to multiply one thing by 1½ you got to multiply the other. So 2.5 times 1.5, 2.5 times 1.5 is 3.75, which is 3¾ All right. Maybe 1 or 2 more. Let's just try that happy medium of 15 minutes. For all non-zero values of x, what does this equal? Well, this is actually a problem straight from our current unit that we've been in Unit 7, reducing rational expressions. So, is there a GCF that we can factor out of the top? Of course there is. They're both divisible by 3, and they share x squared. So I'm left with 4x to the 4th minus 3. You see how we can put that back together? And this is over 3x squared. Well, holy cow, we can just completely cancel that out, and we're left with 4x to the 4th minus 3. Option E. Easy. Good thing we do our class. 4 matrices are given below. Which of the following matrix products is undefined? You may have never seen matrices in your life. And you know what? In all honesty, for the sake of this video, I'm going to skip it so I don't go on way too long. Let's do one more. So 48 was skipped. I'll cover that in class. This graphing one looks daunting too. You know what? Let's just call it there. Let's just call it there. Eh? We did 7 problems, and that leaves us with only 13 in class. So I like the sound of that. All right, so let's have a question pop up on screen so that way I know you made it to the very end. Let's see. What should I ask? Rate your confidence level. All right, I'm just going to say it. Rate your confidence level from 1 to 5 on how you're feeling on the ACT. So question pops up on screen, and the video is over. Thanks for watching. Thanks for learning. Thanks for studying. And I will see you in class. Ta-ta for now.